Good day, physics champion. Today we're going to continue part 2 that we already started a few days before, from question 1 to question 20, last period from October, November 19, paper 2, variant 1. So I'm going to start today with question 21. Then when we finish the paper, I'm going to go directly to the examiner report to see where was the most difficulties that faced the students during this exam. Let's get in. Question 21. A large hell blocks the direct path between a transmitter of radio waves and a receiver, as shown. So as you see, the transmitter sends the signal and it's supposed to reach to the receiver, and it could pass through the hell. But actually, because they mention here in the second line, the receiver picks up the signal from the transmitter, even through the radio waves, do not travel through the hell. That's why I get like this, because they mention clearly, the signal cannot travel through the hell. And they said, which row is correct? A possible way for this to happen is diffraction or refraction. I'm going to exclude refraction because actually there is no two different mediums here to let the signal transfer from a medium then another different medium, because the hell, it cannot be considered another medium because the signal cannot travel through it. So C and D both out of the game. So we still have two diffractions, A or B. Let's see the second column of the table. They said a stronger signal is received using a longer wavelength or a shorter wavelength. In this case, it could be longer wavelength, because if the wavelength was as long as possible, gonna receive to the receiver with a very high energy. So I'm gonna write here stronger signal. It could be received through longer wavelength. So I'm gonna choose longer in both, and I have diffraction here for A and B. So depending on that, the right answer will be A. Right? That was in question 21. In question 22, the diagram shows the image of clock in a plane mirror, which is the actual time you could read here. Normally, I could read it's 15 minutes to 5. So I'm going to write it's 15 minutes to 5. It means now it's 3 something, but it's not mentioned even in the answer, which make it a little easy. But I can feel it like here. If that was 6 and here we have 12. So because I know the image in the mirror should be reversed. So in that section before 6, in a state of 5, it's going to be 7. And here we have 8. So depending on that, even that one, here we have 3, and here we have, sorry, this is 5. This is 15 here, the reading. And that reading here is going to be 45. So I'm going to reverse them because of the image. So here we have 45, and this is 15. Right? So I still read it right now. It was so clear, like it is between 7 and 8. So I'm going to choose 7. 15, it's so clear it is 7:15, because impossible to go towards 7 when it passed through it. So once it's between 7 and 8, it means the time will be shift from 7 to 8. So it is 7 and 15 minutes, as we mentioned here in the figure. So the right answer here is C. Guys, I want to tell you something. If you get confused in such these questions, you can use your calculator or the back of the geometry set to see the image again through that mirror. Like I can use my screen of the calculator as a mirror, then I'm gonna put the screen closer to the figure, so I'm gonna see the image again, and it will be formed in a right way, right? So if you do that, you found the time is 7:15. In question 23, about lenses, a converging lens produces an image of an object O. The focal length of the lens is F. Which position of the object produces a visual image you know, we said that this is the only case if the object was too close to the lens. So it's so easy from the question. I'm going to go directly to A because here the object is on a distance less than the focal length. But actually here, the image will be real. Here still real. Here still real because actually it's before F. So once it's before F, so the image will be real. And at F, most probably the image will be formed in infinity. And between F and optical center, the image will be formed virtual. So the right answer here is A. In 24, they said the diagram shows the electromagnetic spectrum from gamma rays, X-rays, ultraviolet, visible light, infrared, microwave, radio waves, and they said increasing, then dot, and there is an arrow here. So when I transfer from gamma rays, then X, then ultraviolet in this direction, the only thing that could increase is the wavelength. So I'm going to write here, it's the wavelength. This is most probably that they're going to ask about it. And keep in mind, you know, when you go here to the radio waves, the wavelength is long, and the frequency is low. And a gamma rays, the frequency is very high, and the wavelength is short. So depending on that, it means increasing wavelength when you transfer in the direction of the arrow shown. So the word missing here is, I'm going to go directly to D. This is the wavelength. In 25, which row gives a possible set of values for the speed of sound in ice, in water, and in steam? And let's see. They said here the speed of sound in ice, this is the speed in solid, and it's supposed to be the maximum. Speed of sound in water, this is, it should be in between. Speed of sound in steam, this is supposed to be in gas. So let me tell you something, you know, the speed of sound, it's directly proportional with the density. Let me write this piece of information. The velocity of sound is directly proportional with the density of the medium. So depending on that, I'm going to choose the lowest speed for air. And you know, if there is no steam in air, so the density will be less. So the speed of sound in air, it's around 330 meters per second, right? So 500, it's a little bit closer to that number because of the high density for the steam. It contains some molecules of water. So the speed of sound in water could be a little higher. It's much higher comparing by air or steam. So, but it's not like 4,000. So I'm going to go directly to that two options. Yeah. And the speed of sound in ice, so it's like the speed of sound in solids. It's very high speed because of the density. But remember, you know, the density of ice is less than the density of water, but it's still solid. So in solid, even if the density is less in case of ice, it's gonna be 4,000. Right? So I'm gonna use this fact here in case of water, even in steam, but actually still the speed of sound is very, very high when it comes to the state for the solid state. Like the speed of sound is much higher in wood comparing by air. Because or even comparing by water, even if the density of wood is higher than or the lower than the density of water. So I'm going to go to 4,000 in case of ice. So depending on that, the right answer here will be D. This is the common right. In question 26, a steel bar is placed in an eastward direction for it to be demagnetized. No other magnet is nearby. Which method is not suitable? We know how to demagnetize it by hammering the bar. This is, I have no doubt it's fully right, but it seems, you know, we need to continue the question, like heating the bar to a very high temperature. Yes, so this is correct, and this is also correct. That's why both cannot be chosen. Slowly taking the bar out of the coil that carries an alternating current. This is also correct. So the only wrong answer here, because of that not, is slowly take the bar out of a coil that carries a direct current. Actually, the direct current is usually used to magnetize the magnet, not to demagnetize it, or magnetize the magnetic substance instead of demagnetize the magnet. So I'm going to choose D because this is the only not swearable method. In 27, a plastic rod is rubbed with a dry cloth. The rod becomes positively charged. Why has the rod become positively charged? You know, we have two options. We could say that, the positive charge received or the negative charge left. So the idea here, gaining electrons or losing electrons, this is the correct idea. So depending on that, if it was positively, because some electron already has been lost. But when it comes to gain neutrons and protons, they cannot transfer easily out of the atom. Forget about it. So the right answer here is supposed to be C. That was 27. In 28, a circuit contains a cell. The electromotive force EMF of 2 volts. The current in the circuit is 2 ampere. How much energy is converted by the cell in 2 minutes? We know that energy equal to power times time. So the power itself means potential difference times current, and I still have times time. So the potential difference, they said 2 volts, or EMF, it's 2 volts, times the current, which is 2 amperes, times the time, which is 2 minutes. But remember, that 2 minutes is supposed to be in seconds. So I'm going to say here times 60 to change them into seconds. And depending on that, the right answer will be D. When it comes to my calculations, it's D. So 2 times 2 times 2, it gives you 8. 8 times 6, it gives you 48. Then I have 60. It means one more zero should be located here. And the measuring unit is joules. So this is how to go through this question. And 29, the circuit diagram shows a cell connected in series to a resistor and a component X. Fine. What is the component X? It's diode. I like this question. It's just to pick up your time. Identical resistors are connected together to form arrangements X, Y, and Z. So what is the correct order for the resistance of the arrangements? From the largest to the smallest. Largest, it's supposed to be that one because it's series, 3 series. If they were identical, so 3 better than 2 or larger than 2, then this is the second one because they are just only 2 in series. And when it comes to 2 in parallel, so the resistance will be less than the smallest one. So I'm going to write here, this is number 3, if we start from the largest to smallest. So depending on that, I just want to say something. If each one represent R, so the resistance here will be 3R, the resistance here will be 2R, the resistance here will be just R divided by 2, because it is parallel. If you remember the law, R times R divided by R plus R, it means R squared, divided by 2R, it gives you R divided by 2. So depending on that, the right answer will be Z, then Y, then X. So the right answer here is D. That was question 30. In question 31, they said a circuit contains a cell of EMF 2 volts, 3 resistors, 3 ammeters, and 2 voltmeters. 1 ammeter is labeled B and 1 voltmeter is labeled Q, as you see in the figure. I can observe that. So V and Q, 1 ammeter is labeled Q and 1 ammeter is labeled B. Okay, fine. The question is, what's the reading on ammeter P and what's the reading on voltmeter Q? Let's see. The total current is 2, as you see here, and the current here is 0.8. 0.5, it means node 2 could equal 0.5 plus p. Depending on that, p could be 2 minus 0.5, which is exactly 1.5. So I'm going to go to that option, the reading of the ammeter P. It's 1.5. Then let's check the voltmeter. The voltmeter, because they connect seriously, the group parallel with the one resistance series. So the potential difference here, it's supposed to be 2 minus 0.5. It gives you again 1.5. So I will go to that option, 1.5 for both. So depending on that, the right answer will be A. And here is the calculation, you can check it. In 32, there are 2 inputs and 1 output for a combination of logic gates shown in this figure. So I have 2 inputs and output. The 2 logic gates that we have here in 32, it's NOT, and here we have A and D, or AND, A and D. So which truth table represents the operation of this combination of logic gates? Let's see. If that was 0, 0, so the right answer here, the output after NOT is going to be 0. So after AND, it's going to be 0. So I'm agree with C and D, both are wrong. So let's see what we will have in A and B. If it was, I have some difference here between them, which is in the last one, 1, 1. Okay, so when we consider the input 1 is 1 and input 2 is 1, so the NOT gate, I'm going to give you 0, the product after NOT gate is going to be 0. So the inputs for AND, it could be 1 and 0, so it's supposed to be 0. So it could be 1, 1, 0, so 1, 1, 0. So I'll go to that option, right? Option B is correct, but A is wrong because of that step here. So the right answer here is going to be B. And question 33, where must a fuse be connected in a mains electric circuit? You know, fuse, switch, a circuit breaker, whatever we have, it could be in the live wire. So that was easy. Just go through that. The right answer here is B. It's supposed to be in live wire. Any component in the circuit, like switch, circuit breaker, or fuse, all that, it's supposed to be on the live wire. 34, students investigates the output voltage induced across a coil of wire by a bar magnet. When will the induced voltage have the greatest value? The rate of cutting should be high as possible. So let's see. The student slowly moves the bar magnet into the coil of wire. So the word slowly here, it means the rate of cutting will be less. So I will not go through that option. It does not compatible with the word greater. The student leaves the bar magnet stationary in the coil of wire. Actually, stationary here, it means there is no cutting at all. The student quickly removes the bar magnet from the coil of wire. I agree with that initially. I have no doubts this could be the right answer. The student places the bar magnet at rest outside the coil of wire. Actually, at rest it means there is no cutting for the magnetic field lines. It means there is no current induced. So I will go to option C. This is the only one which is suitable. In question 35, there is a current in a wire. The direction of the current is out of the page. Which diagram shows the magnetic field pattern? Let me show you that in the board. Like in question 35, you're going to use my left hand rule. So in question 35, as you see here in the board, the current, they said there is a current in the wire. The direction of the current is out of the page. So I'm going to do that. The direction of the current is out of the page. This is what's meant by this dot. So the direction of the current is out. I'm using my right hand. Then the magnetic field lines are going to rotate around it. So this is not compatible with this one. This is fake. I have two different directions here. So A is wrong. B is the right answer. This is if it was electric field produced by static charge, right? Here, if we have positive charge, and here, if we have negative charge. So D and C out of the game. The two different directions for A out of the game. The right direction is the current out of the page. Magnetic field lines rotate around it. This is exactly compatible with B. So I'm going to go to option B. I'm going to go to option B here. So the right answer will be B. In 36, diagram 1 shows a coil of wire P between the poles of a magnet. The ends of coil P are connected to a battery by slip rings. Diagram 2 shows a coil of wire Q between the poles of different magnet. The ends of coil Q are connected to a battery by split ring commutators. You see here? What happens to coils B and Q? Let's see. Coil Q, it could rotate normally, right? Because I have something to change the direction of the current, to change the direction of the force acting in coil here, Q here. So these two split commutators will change the direction of the current, which is already DC. So the force acting on the coil will be changed each turn, or we can say each half turn. So it means the coil will keep rotate. But in this case, the coil will flip to be exactly vertical and stop. This is what I understood from the figure. Let's see what we have here. Coil P continuously turn anticlockwise? No. Makes 1/4 turn anticlockwise or make 1/4 turn clockwise. So actually, it's going to be one of them. Let me check the other. Coil Q, we didn't use our right-hand rules or left-hand rules right now, but let's see. In coil Q, it's gonna keep or continuously rotate. So actually, this two answers out of the game, exactly like this two answers out of the game. So now let's check the direction for Q, for example. Positive charge, negative charge, the current is directed in that way. Then here, then back. This is the instant that we have in this image. And actually, this is a motor, so I'm going to use my left-hand rule. So if I use my left-hand rule and I'm going to apply it for that section wire, so I'm going to draw my left hand. So the direction of the magnetic field lines from N to S, so this is the direction of the magnetic field lines. As you see, it's compatible. The current is out of the page, so this is the current. So the force will be up. So the force acting on that piece of wire, it could be up. It means in the other direction, it's supposed to be down. It means the direction of rotation, if my eye is here, imagine this is my eye, I'm going to observe it. So the direction will be, for my eye position here, it could be anti-clockwise. So I'm going to go to that option for coil Q. So depending on that, the right answer will be C. It's anti-clockwise. So I will choose C. In question 37, which diagram shows a possible structure for a neutral atom? The neutral atom, it means the number of positives should be the number of negatives. So be careful about that and that one. So we have electron outside, rotate around it, one proton. So I will go directly to option A here. It's very clear. We have one electron outside and we have proton and neutron inside, and they are neutral. The number of protons equal to the number of electrons because it's neutral. In 38, the scatter of particles by a thin gold foil provided scientists with evidence for nuclear atom, which particles were scattered by the gold nuclei in the thin foil. You know, Rutherford, he already used alpha particles. They didn't ask you why. You just need to give the answer, which is alpha. So Rutherford experiment, he used alpha. Question 39. The diagram shows beta particle being directed between the poles of a magnet. So in which direction will the particles be deflected? Remember, consider it's alpha. If it was alpha here, and it's moving in that direction, I'm going to use my left-hand rule exactly as we did in motor. So from N to S, do that. So from N to S here, and the direction of alpha towards me, so the force will be into the board. So it's going to be deflect alpha. Alpha will be deflect into the board. So beta, it could be outside the board. So this is what I write here. Alpha, it could be outside the page. So I'm going to go to option B. B is the correct answer. The last question, why are some radioactive sources stored in boxes made from lead? You know, in such these cases, lead absorbs emissions from the radioactive source. I agree with that. Decreases the half-life? No, it cannot be decreased. Lead increases the half-life. It cannot be even increased. Lead rebels emissions? No, actually, it's fake. There is nothing like this. It's just we can say absorbs that, so it gives some protection for the people. So the right answer here is A. Thank you for the watching. That was the end of the paper. If you feel that such these videos important for you, please do subscribe for the channel and see the next video. Thank you.